All right, we're trying to divide the two following imaginary numbers. And in order to do that, we want to write your answer in the form a plus bi. So essentially, when you divide two imaginary numbers, it should eventually give you a single imaginary number. And the way to work with this is to focus on the denominator. So we have 7 minus 4i over 4 minus 5i. And the denominator is 4 minus 5i. And what we want to do is multiply by the conjugate, what's known as the conjugate of 4 minus 5i. So the conjugate of that is, so we're going to be multiplying by 4 plus 5i on the top and bottom. So if we multiply by the same thing on the top and bottom of the fraction, then essentially we're multiplying by 1, and we're not changing the problem at all. But what's really interesting about this is that the imaginary part of the denominator goes away, and you only have a whole number, a real number remains. And we'll see how that works out. Okay, so the denominator will give us. Actually, I will go ahead and do this on the top here. So 4 minus 5i times 4 plus 5i. Multiplying that out, notice that 4 times 4 is 16. Then 4 times 5i is plus 20i. And then we move on to negative 5i times 4, which is negative 20i. And then we have negative 5i times a positive 5i, which is minus 25i squared. So you may know that I squared is equal to negative 1. Using that, we can simplify this and get 16. Notice that the plus 20i minus 20i, they cancel each other out. They're the opposite of each other. So when they add together, you just get 0. So we're left with minus 25, and then multiplied by negative 1, because I squared is after the 25. And remember, I squared is negative 1. So that gives us 16 plus minus, then that's a negative number. That'll give us 16 plus 25 is 41. So the denominator becomes just a whole number, as I mentioned before. It's a real number, 41. And what we'll want to do is multiply just the numerator together. Let's go ahead and do that. It's going to be very similar to what we did up here, but it's not going to simplify so nicely and just have a whole number. It's still going to be imaginary. So 7 minus 4i times 4 plus 5i. Multiplying this out, we would get 7 times 4 is 28. 7 times 5i, both positive, so that would be plus 35i. Negative 4i times 4 is negative 16i. Negative 4i times positive 5i is negative 20i squared. Remember, I squared is negative 1. Remember that when we do this next step. So that would be 28 plus 35i minus 16i. So 35 minus 16 is 19. So that would be plus 19. Oh, too many times. Plus 19i. And then minus 20i squared. That'll end up being negative 20 or minus 20 times negative 1. And still it's over 41. Don't forget that. So 28 plus 19i plus 20 over 41. So that minus 20 times negative 1 becomes plus 20. Okay, and then we have 28 and 20 added together is 48 plus 19i over 41. And then remember, we want it in the form a plus bi, so we're not quite done yet. Notice that if we have a fraction like this, we can separate it like this: 48 over 41 plus 19i over 41. But even further, we want to bring that I out in front of the fraction. So our final solution will be 48 over 41 plus 19 over 41 and then multiplied by I. And that is our final solution. I hope this didn't confuse you on any of these steps. There's a lot of little steps that I might have just jumped over a little bit. But I try to go in depth as much as possible. But if you do have any questions, please let me know, and I'm more than happy to help. So yeah, good luck and happy studies.